Okay. As I mentioned, we've done the limit process. It's not fun. So let's move on to something that makes our lives a little bit easier. And many of you probably already know this because you learned it, I would guess, in physics. Is that where you guys all got the power rule? No? Just casual learning?
I learned it from my we felt from you once.
Ooh, gotcha. It's not just like a hobby. You did some weekend you looked it up. Okay. Basic differentiation rules. So differentiation is the process of taking the derivative of a function. So if I have f of x, then we would get f prime of x. And then we're also going to talk about the second thing. Actually, we're going to talk about all three things today that a derivative represents. We'll get to all three by the time I'm done here. So we're going to find the derivative of a constant function. A constant function would be something like y equals 2. We're going to learn the power rule, which is huge. Then we're going to do the constant multiple rule. What happens when I take a function and I multiply it by a constant? Are you all okay with the term constant? Yeah, it's a number. Oh, there's a lot to do today. Sum and difference rules, easy peasy. Then we're going to bring some trig in. Everybody loves trig, but we're only going to do 2 of them. We're just going to do the sine and the cosine today. And then we're going to talk about rates of change. Do a little bit of physics. It'll be fun. And then the third thing that a derivative represents is instantaneous velocity. Not to be confused with average velocity, and we'll talk about the difference between the two. Which, again, who's had physics already? Just 2 of you? 3, 4, 5, 6, okay, a whole bunch of people, good. So then you should all be able to explain to me the difference between average velocity and instantaneous velocity when we get to it. Okay, constant rule. Let's think about this carefully. Suppose I have a graph of y equals 2. What would be the derivative of the graph of y equals 2?
Zero.
Is that you kidding?
Yeah.
Y 0?
Isn't that the slope of y equals 2?
Expound a little bit more, please, for those that are confused.
Isn't the derivative just the slope of the
Correct.
function?
And what's y equals 2 look like?
It's a horizontal line, so
Good.
the slope is 0.
Okay. Doesn't matter what the number is. If you take the derivative of a function that is a constant, it's going to be, the function itself is going to be a horizontal line. And as Katie said, the derivative is the slope of the tangent line. Well, the slope of the line is the line itself, its slope. And the slope of a horizontal line is 0. So, new terminology. Whoop-lam. That's a new way of representing derivatives. We've done f prime, g prime, h prime already. Let's get into the other one. dc dx, the derivative of c with respect to x. Okay, so the top d is what function are we taking the derivative of? The bottom thing is which one is my variable. Most of the time, your variable is going to be x. But occasionally, things are going to get a little crazy. You might take the derivative with respect to y, or z, or q, or p. And then, in a couple of years when you get to college, you might actually take multivariable calculus. Some of you just threw up in your mask a little bit, didn't you? Yeah, just the thought of that is disturbing. Oh, by the way, we'll go into a history lesson, though, in a little bit. Not today, but probably next week. Y is sometimes called f prime, and y is sometimes called dy dx. It has to do with Newton and Leibniz, which, we'll talk about later. You don't really care about that right now. Okay, so real simple. If my function is y equals 7, it's a horizontal line that's 7. Since it's horizontal, then its derivative is going to be 0. We're okay with that, yes? Yeah. Okay, good. If f of x is equal to 0, remember f of x is the same thing as y. You will see, by the way, that I'm beating a dead horse here, but I also want you to get familiar with the notation. F prime of x would also be 0, because again, 0 is a constant, so therefore its derivative would be 0. S of t, getting all fancies in my pantsies and changing the name of the function. S prime of t would be 0. So two things happened in that one. Number one, I changed the name of the function to s, and number two, I identified that x isn't my variable, t is my variable. And then the last one, the derivative of pi squared is also 0. Why?
It's just a constant square.
It's a constant. That's going to trick up some of you on the next quiz. Like, what's the derivative of e? 0. E's a constant. I think you get it by now, yes? Yeah. Good. Power rule. Matthew, tell us how the power rule works.
You subtract 1 from the power of, actually I don't have a term for this, like, I don't know, say you have like x cubed, you subtract 1 from the degree, and then you put the original number that the degree was in front by multiplying it. I'm not good at explaining this.
Huh?
2x. Okay, you subtract.
Okay, that's the answer, but how do you, all right, hold on. We've done this ad nauseum. Let's try something different.
You subtract 1 from the exponent.
6.
Yeah, and then you take the original number, as I started with that, and multiply it after subtracting from the exponent by the original number. So like 7x to the 6th.
Everybody got that?
No.
No.
What, you just confused yourself? Did you just say no?
If you just move the exponent to a coefficient?
That's what I would have said, but
Yeah.
he's driving this bus. Yes. Take the exponent, move it out in front, reduce it by 1. Easy peasy, lemon squeezy. And it doesn't matter how big that exponent is. Move it out in front, reduce it by 1. And if you go back and look at some of those problems you had on the homework, like I believe I remember seeing x cubed plus x squared somewhere. Well, that was nasty. When you use the limit process and you go through all that business, you had to multiply out a cubic with x and delta x, and it was horrendous. But knowing this now, what would be this derivative? Oh, hold on, let's get fancy here. F of x. What would be f prime of x?
3x squared plus 2x.
Done. Yes, it's just that simple. There's no catch to this. It's not like I'm going to drop a bomb on you soon and say, oh yes, but unless, no, that's it. That's the power rule. You are going to use that ad nauseum. Have we talked about that term before? Ad nauseum, it's Latin, means until you throw up, until you puke. Okay. So there it is in fancy calculus speak. We take a function, an exponential function, x to the nth. To take the derivative of that, you move the n out in front, you reduce it by 1. All right, sounds great. What's the derivative of x?
0. 1.
Luke,
1.
why?
Because it's x to the first power. So you just, it's 1 times x to 0, which is just 1.
Outstanding. That's one possible answer. Luke, can you give me another example of why it's 1? Or another explanation?
Because the slope is just 1. Or wait.
Yeah, you're right. If I graph that, x is just the 45-degree angle line, which has a slope of 1. The derivative, as we defined, is the slope of the line, which is just 1. Good. Still the power rule, though. Like you said, this is x to the first. Bring the 1 down, reduce it at anything to the 0 is 1. Oh, wait. What about 0 to the 0? Let's not go there yet. No. That'll make somebody cry on a Friday. Let's not. We'll just leave that alone. As it says in red, and it spins. This is really important. That's why it's spinning. It wouldn't make it spin if it wasn't really important. Okay, so, What's the derivative of x cubed? We did this already, but just for giggles. Molly?
2x, or 3x squared.
3x squared, well done. What's the uh-oh. Whoa. All right, what the heck? Alice,
Isn't that the same as x to the, like, 1/3?
oh, hold on. This is the same thing as x to the, as my grandfather would say, the 1/3. Don't leave us hanging.
Well, you're supposed to subtract 1 from the exponential value. So you just subtract 3/3 or 1 from 1/3. That's -2/3. And you move that to the front, so 1/3 x to -2/3.
Huh. Agree?
Yeah.
Yeah, bring the 1/3 out in front, reduce it by 1. 1/3 minus 1 is -2/3. Good. In the future, this will be unacceptable because we don't want negative exponents. But we're going to walk before we run. So if you want to leave it as a negative exponent right now, it's okay. Later on, we'll deal with that. I'm just happy if you can get that. Well done. There it is again. Again, if you want to get fancies in your panties, you can move that to the denominator. Great. How about this guy? Uh-oh. What will we do? What will we do? Faith, any ideas? Not to put you on the spot or anything, but Faith, any ideas?
Since x squared is on the denominators, can it be x to the -2 power?
You can, you bet it can, or you can it bet. I don't know why it came out that way, I'm sorry. I've had too much caffeine.
So then you'd move the -2 to the coefficient and then subtract 1 from -2, and that's -3 for the power.
You would not believe how many times I have people tell me it's -2x to the -1. Holy guacamole. -2 minus 1 is -3. And if you were feeling all fancies in your pantsies, this would become what?
1 over -2. Over x cubed.
-2 stays up on top. Good. Okay. But again, at this stage, I'd be happy with that. Okay, good, thank you. Okay? Yeah, that's what it says under all that mess. Great. Also, but I mean, you should know this, but you know that -2 over x cubed is the same thing as the opposite of 2 over x cubed, is the same thing as 2 over -x cubed, yes? Okay, good. It's not the same thing as -2 over -x cubed? All right, just want to make sure everybody's on the same page so we don't make silly mistakes. But silly mistakes would imply that there is such a thing as non-silly mistakes, which there aren't, so all mistakes are silly. So we'll just call them mistakes. Sorry, I went off on a tangent there. Went off on a tangent there.
That's good.
Nice, nice. Constant multiple rule. What if I have a function that already has a coefficient? So let's suppose we go back to this beast of x cubed, but instead I stick a 5 out in front. Oh, I don't know what little old me's gonna do. Ideas? Dexter.
15x squared.
15x squared is the proposal on the floor. Could you explain, please?
Doing the same thing, multiplying the variable x by 3, and 3 times 5 is 15, and then I'm subtracting 1.
Perfect. This is the same thing as 5 times x cubed. That seems like a silly way to write it, but if you take the derivative of x cubed, you get 3x squared. 5 times 3 is 15. So you just multiply that exponent by the coefficient out in front, and life is grand. There's the fancy way of saying it. Okay. if you want to, if you're feeling even crazier, you could take that c and throw it all the way out there if you'd like. Doesn't matter, you just multiply. Okay, so I'm just going to go through this pretty easy. Yeah? Okay, good, yep, yeah. Sum and difference rules. This one's ridiculously easy. The derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. So, example-wise, let's go with g of x to the fourth minus 2x squared. The derivative of a difference is the difference of the derivatives. So therefore, what's g prime of x? Mason? Sorry, Mr. Zimmer?
Wouldn't it would be 4x cubed minus 4x.
Well done. Just break it into parts. Take the derivative of each term, make sure you add and subtract correctly, we're done. And there it is in fancy calculus speak. The derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. Okay, we did something like that already. Quickly, M, what is that? Hurry, speed is important. No, I'm kidding, it's not. It's math. We don't really care about speed. Go ahead. Speed kills.
3x squared minus 1 plus 5. Because that would just be 1 because it's x is 0.
Somebody
3x
else?
squared
Oh,
minus
hold on.
6.
Go ahead.
3x squared minus 6.
No.
X becomes 0 plus 1.
So
1 times
I'm going to give you that. You rock that one.
Thank you.
This one's freaking you out a little bit. Luke?
4.
I'm sorry?
4.
Oh,
I'm sorry?
4. Negative 4.
Negative 4. Good, good, good.
negative 4 plus 5.
Oh, uh-oh. How about that guy? Not what?
You just don't put it.
You just ignore it. Right. It's like that kid in class picking his nose. You just pretend you don't see it. You just move on. Yeah.
It can't hurt us.
What's that?
It can't hurt us. It can't hurt us.
Well,
It can't.
it could. Yeah. But anyways, derivative of a constant is 0. That one disappears. We get that. Okay. More of the same. That's a 1/2, by the way. Take the derivative, you get that. 4 times a half is negative, or negative, sorry. 4 times negative 1/2 is negative 2, reduced by 1x cubed. 3 times 3 is 9, x squared. And the negative 2x, we talked about that in the one in part 1, which would just be negative 2. Let's take a break, shall we? It's 2:30, just about. Time to see the dentist.
2:30.
2:30. Shut up. Take 5 minutes, go.
Yo.
I know, why is it something?
At like 2x. Negative x.
Mr. Reed, do you think I would need a pass to get out?
I don't know.
I think I might.
Yeah, go to the attendance office. Tell them what you're doing.
Okay.
I mean, you can't be the only one that's leaving early, right?
No, yeah, there's
all
only
teams. But I would check in with the attendance office just to be sure.
Sure.
Oh.
Oh, well, oh. It's okay. She died on me. Okay, so is it technically 1/2 x to the 4th? So then if you put the 4 over, it's negative 2 and then subtract 1. Yeah, okay, that makes sense now. I was like, oh,
The
slashes always confuse me.
I know. They confuse me too.
I don't know why.
I don't even know why I say that. I literally use them. So that doesn't make any
I'll
sense.
post the slideshow's already up, but I'll post the video later
You
today.
are
and-
yourself that notice.
Don't do it over the weekend.
Yeah.
Okay,
Yeah.
thank
Say
you.
you slash with someone else, but like, I'm not sure what the numerator is.
For real.
Smart, so he's taking
Physics, fun. Love it.
That's just not right.
we both.
I would like to go. Oh. Me too.
Okay, yeah, no one see the original dog.
Yeah.
Well, we can't even grab it.
No, you can't do that.
No, you don't want to see
You're
it.
not
Oh,
supposed
I
to.
wanna see it.
Some people did.
No.
But you're not supposed to.
I don't mind seeing it, I have to simplify.
That's too many.
I just clicked on chocolates to turn in my physics.
Oh, God. I've done that one too.
Okay.
Wrong course.
One last thing to deal with, and that is the trig functions. There are 6 of them, which I'm sure you're all well aware. We're just going to deal with 2 of them today. The sine and the cosine function.
Sorry.
What do I want to say about this? I am not a big fan of memorization. However, this is something where you're just going to have to memorize those 2 things. The derivative of sine is cosine. The derivative of cosine is negative sine. You will screw up on that sine a lot. Sine, S-I-G-N, not S-I-N. The derivative of sine is cosine. When you take the derivative of cosine, a minus sign appears.
Negative one.
Why is it?
Why is it negative?
That's not an easy answer. Yeah. I'm going to implement the because I said so theorem. Okay.
Just Google it.
Yeah, here you go, Google it, you'll find a 30-page paper explaining why there's a minus sign. Okay, so
Should be able to figure out.
what's the derivative of 2 times the sine of x? Josie, what's the derivative of 2 times the sine of x? Close. Oh no, actually that's right. I screwed up. Remember that thing I said about screwing up on this S-I-G-N? Yeah, I just did that. Oh boy. What's the derivative? This is silly. It's the same thing. It's the 1/2. What about that guy? Oh, there we go. There we go.
I'm scared.
Don't be scared, Adrian.
No,
What is it?
Oh,
X minus, wait, yeah, X minus sine.
What's the derivative of x?
1.
1.
So 1 minus sine of X.
1 minus sine of x. Well done.
Thank you.
Rates of change. What is a rate of change? It's the amount of change that something does and how fast it happens. You probably know the most simple rate of change would be slope. Change in y over change in x. We're going to get a little bit more in-depth in that, but this is the second thing that a derivative represents, the rate of change in a problem. Okay, so slope, yeah, rate of change, said all this already. A wide variety of fields. Population growth, production rates, water flow rates, velocity, acceleration. I should have put in there the spread of disease, the rate of contagion, if you will. Like for The Walking Dead, you know, zombies. How fast zombies spread would be a rate of change. Zombies per day, if you will. Possibility, right? It's a rate of change. So we get into a little bit of physics here. S of t represents a position function. Where is something at a certain time? And I'm sure, just like in physics, you saw all kinds of instances. What is that something? Is it a car driving down a road? Is it a ball on the end of a pendulum? Is it a spring bouncing up and down? There are a lot of different things that we could deal with. We are going to use, however, the KISS method. We're going to keep it simple, stupid. Rate equals distance over time. You will commonly hear me refer to this as the dirt equation. Have you ever heard that before? Distance equals rate times time. Dirt. If you want to do distance over time, you can. Why did I do it as distance over time? Because we're talking about a rate of change. But again, the dirt equation is what we're going to implement. If I drive 50 miles an hour for 1 hour, how far do I travel? 50 miles. Good. Keeping it simple. If I drive 100 miles in 2 hours, what's my rate? 50 miles per hour. Okay, again. Average velocity is just that. It's the average velocity. If I leave here today and I drive to see my daughter in Minneapolis, and it takes me 6 hours to get up there, and I know the distance is 400 miles, just making it up, I actually don't know what it is, you could calculate my average velocity. Yes? Are you all with me on that? So let's suppose when I do that average velocity, it turns out to be 50 miles per hour. Does that mean I was doing 50 miles an hour the whole trip? Did I pull out of the Prospect parking lot doing 50 miles an hour? No. Did I pull into her parking garage doing 50 miles an hour? Was I doing 50 miles an hour the whole time? The answer is no. Sometimes I will have stopped to get a drink. Other times I would be driving faster than 50 miles an hour because it doesn't appear to be any police around and I'm in a rush to get up there. You understand what I'm saying, yes? Distance divided by time, or the distance is equal to rate times time. That's average velocity. For our purposes, the average velocity is the same thing as the slope of the secant line. So remember the other day when I had that graphic, I had the point P and I had the point Q. When I connected those 2 points and we calculated the slope, that was the average velocity. Okay? It's also known as the slope of the secant line. Delta S over delta T, delta Y over delta X if we're talking about a graph. What would be an example of my instantaneous velocity in my trip to Minnesota?
Don't say anything. Tommy, this one's all you.
Go ahead.
So you're hopefully not moving in the stop sign?
Yes. Correct. At 7:05, I stopped at a stop sign, and therefore my speed at that moment in time was 0. At 8:30, I was flying down 94, doing 85 miles an hour. Okay, instantaneous velocity is the speed you're doing at an exact time. That is represented by the derivative. There's our third thing, instantaneous velocity. So a derivative is the slope of the tangent line, it's a rate of change, and it's an instantaneous velocity. So for those of you that have physics, or had physics, you know that we can do all kinds of calculations. For instance, if I pick up Adrian, and I throw him out that window, could we calculate how far off the ground the window is?
Yeah.
Yes. What would we need to know? Other than measuring the height of the window, that would be silly. That's crazy talk.
Height of the ground.
Say again?
Height of the ground and height of the window.
Well, that would be cheating. If I just throw him out the window, could we calculate how far off the ground the window is?
Oh, yeah.
What would we have to measure?
The path you made, and then like divide that by the, gravity, and then, what else? Distance, I guess.
fancies and fancies. Nice. What path, by the way, what path would he follow outside the window? Yeah, an inverted parabola, good. So let's suppose I threw Adrian out the window and me. Okay. Yes, I guess I would have to throw myself out the window. I weigh considerably more than Adrian. What do you weigh, like $110?
Yeah, something like that.
Okay, so I'm almost twice your weight. I'm probably, if you are, you're not 110 pounds, are you?
No.
Okay. You're more than that?
Yeah.
Okay. You don't want to tell us?
No.
I understand, okay. So let's say he was 110 pounds, I'm twice his weight, who's gonna hit the ground first? No, neither one of us, we hit at the same time.
In a vacuum.
Correct, yes, yes. I'm assuming he doesn't tuck into a ball and I open up like a flying squirrel. If we're both tucked into balls, theoretically, we would hit the ground at the same time, like weight doesn't matter. Okay, so in this case, we're dropping a billiard ball from a height of 100 feet. Not something you want to get hit with. That equation probably looks familiar to you that have had physics. -16 is the acceleration due to gravity. That's not important right now. From a mass standpoint, I know the position function at any point in time is given by that function. So when t equals 0, I know that the ball has a height of 100 feet. Because if you plug 0 in for t and solve, you get 100. At t equals 1, I know the ball's going to be at a height of 84 feet. Did I get that right? Yes, I did. 100 minus 16 is 84. And you get the idea. In order to solve these problems, however, I want you to take a calculus understanding of what's going on. I have this function, -16t squared plus 100, which is an upside-down parabola. Looks something like that. Okay. And I want to calculate the average velocity from t equals 1 to t equals 2. Okay, so from t equals 1 to t equals 2. Average velocity is the same thing as the slope of the secant line. So from a graphical standpoint, what I mean by that is the slope of this line. Can you find the slope of that line? What chunk of information are you missing? Where is the ball at t equals 1?
$74.
84, very good. So this point is 1, 84. Everybody with me on that one? When t equals 1, I plug 1 into the function, I get 84. Where is the ball at t equals 2? Say again? 36 divided by 2 is, not that I don't trust you, but yes, you're right, 36. Now, could you calculate the slope of that blue line? Yes. So from a calculus standpoint, what we're doing is we're taking s of t, we're taking s of t plus delta t, subtracting that and putting it over t plus delta t minus t. That should look familiar, yes? That's the difference quotient. What's missing is the limit. We'll get to that in a second. Okay, so that's average velocity. Instantaneous velocity would involve finding the derivative, which we'll come back to in a second. Okay, so plug and chug, we got the 84, we got the 36, you calculate the slope, and we get -42 FPS, feet per second. Why is the answer negative? Say again?
The slope is negative?
Yes, mathematically speaking, the slope is negative. From a physics standpoint, why is the answer negative? It's going down, correct. That's moving pretty fast, by the way, with a billiard ball. You kill me. I don't know why I made it do that. I'm sorry. Second one, same idea, different numbers. So we still know what t of 1 is. You find what t of 1.5 is, calculate the slope, negative 40 FPS. So it's not going as fast after only a second and a half, because again, it's accelerating due to gravity, and I'm sure you understand that from physics, but this is math. Okay? How are we doing so far? All right, good. Good. Now the instantaneous velocity. So this little guy right here, we just did. That was the average velocity. Velocity. But now, when I stick the limit in there, it becomes an instantaneous velocity. Okay, well, what does that mean? Going back to the picture we had before, right? Come on. Here, when I take the limit, I'm going to take this point, and I'm going to slide it closer to that point. In other words, I'm going to take the limit. I'm going to reduce delta x to 0. And when you do that, you end up with a tangent line. God, I can't hit a tangent line to save my life. Big honking dot. There we go. Hit it perfectly. Okay, so we did that. Oh, sheesh. It's a derivative of the position function. If you had physics, you know that velocity can be negative, it's going downward, could be 0, it's not moving, or it could be positive, it's going upward. Speed is the absolute value of the velocity, must always be negative. I think, I'm not 100% sure, but if you put your car in reverse and drive backwards, what does the speedometer do?
Can you say that speed always has to be negative?
Did I say negative?
Yeah.
Well, that's ridiculous. It's got to be positive. I don't know why I said negative.
Okay.
Again, too
So
much
if you
math.
still go in reverse, your speedometer still goes up.
Well, that's what I'm wondering. I mean, a car registering your velocity or your speed? I think it's speed. So here's your experiment. When you get out in your car today in the crowded parking lot, slam it into reverse and just gun it. Well, when you do that, take a look at your speedometer to see if it's positive or it does a needle. Well, if you're digital,
Behind you.
how many people have digital speedometers on their car? Look and see what the number is. Is it registering like 35 miles an hour backwards? Or is it registering as negative 35 miles an hour? Okay, and then do one of those James Bond turns, and then go straight forward and see what it does to the speedometer. Okay. Just to cover myself legally, I need to say, because I am recording, that I was kidding about me flying in reverse through the parking lot right after school. Okay? Wait till 12:30 at night tonight and then do it. Again, also joking. I'm kidding. Don't do that. Okay? Just don't do any of that. That's too dangerous.
Perfect timing, I just got new tires.
Awesome. So, again, the derivative is that instantaneous velocity. And I think, personally, that the instantaneous velocity is easier. Because if we go back to this ball falling, get rid of all this mess. I throw the ball down. I don't throw the ball, I drop the ball. How fast is the ball going after 3 seconds? So, instantaneous velocity, so I take the derivative. Can't write with an eraser, knucklehead. S prime of t. All right, what's the derivative? Just shout it out. Just, whatever you got. Just
Negative 32 t. I don't know if that's right.
yeah, it's perfect. Yeah. Remember, the 100 disappears. It's constant. So therefore, S prime of, what did I say? 3?
Yeah.
3 would be negative 96 feet per second. That puppy's cooking. That's definitely going to hurt somebody. Okay. Or bury itself in the mud. Or hit Adrian, who's laying right below the window when we drop the billiard ball on him. That would be fun. Yeah. If the fall didn't kill you, the billiard ball will. Okay, how are we doing so far? Good, so let's go diving. Okay, we got a diver. Get her up on a platform 32 feet above the water. The position function of that diver is given by that equation. In physics, I'm guessing you would have to come up with that function on your own, yes? Yeah. Part A, when does the diver hit the water? So what's true when the diver hits the water? Say it again, Kate.
Equal to 0.
What's it?
That's an item. So the equation.
Perfect. The equation is equal to 0. 0 is equal to negative 16t squared plus 16t plus 32. Solve that, please, and tell me what t is. I'll wait. By the way, you're going to need your calculator, so you might as well just get them out. You should have a quadratic formula on your calculator. Save yourself some hassle, plug and chug into the quadratic formula. You don't want to be factoring and you don't have to. Quadratic formula. Does anybody not have a quadratic formula on their calculator? Shut the front door. Why?
Yeah, I don't know what you mean.
Yeah, me
What?
No, I don't. You know, there's a calculator where you can tag the program, the calculator.
Okay, so for those of you that don't, I will get it to you not today, but on Tuesday. It is one of the most useful tools you'll have in this class. It's a nice little program on your calculator that will do that for you. Somebody that does have it, please tell me what it equals, AJ. 2? And? Negative 1. Because it's a quadratic, we must have two answers. Oh, Adrian?
Yes.
Which of those doesn't make any sense whatsoever?
-1 doesn't.
Negative 1, because this diver is not Marty McFly.
Are you sure?
That would be cool.
Anybody? Do you get the reference?
Yeah, Star Wars.
You pack up your stuff and you get out of this room right now. Is that you, Matthew?
Yeah.
Yeah, you are done, mister. Star Wars. Everybody knows it's Star Trek. Marty McFly is the guy from Back to the Future. Okay, so be -1, you'd have to go back in time. So therefore, and I'm referring to the diver as a he because it's only wearing trunks. So if it is a she, we don't want to go there, so we'll just assume that it's a he. It takes 2 seconds for that diver to hit the water. We throw out the -1 because it doesn't make any sense in the scenario. The big question is, how fast is he going when he hits the water? Is that an instantaneous velocity or an average velocity? Instantaneous. And so we find an instantaneous velocity by taking a derivative. S prime of t is equal to negative 32t plus 16. And we want to know S prime of what? 2. What is S prime of 2? Good. Negative 48 units here, feet per second, FPS. Okay, that's moving pretty quick. 32 feet would approximately be a 10-meter platform. So you'll see, like if you watch the Olympics, when the 10-meter divers hit the ground, they usually interlock their hands so they don't punch themselves in the face. But that's moving pretty fast. Okay? Questions? We're going to start easy. By starting easy, I mean most of the functions you see will be quadratics. You should be masters of quadratics. Time that better. Oh, look, I got all the answers right. Yay! I'm so smart. It's a no homework weekend. Yay!